What? Okay, why? It's just okay. It's just quiet. Okay, YouTube stream's up. Hello, Joseph integrates. Hello, good to see you on Twitch. Bread God, hey. Jed first on YouTube, nice. 750, hey. Niarcher. That sounds like a version of Linux, maybe for weebs. Hey Joseph. Oh my god, this freaking this little ray of light here is gonna be the death of me. Claim i3 before it goes to 4. Hey Jed. Can change your lights 3.5 times. The lights are allegedly no, they are actually set up back behind me, but I don't see the light coming. Ooh, you can see the reflection off the closet. I think that's them right there. They're currently on orange. You know, let's experiment. Hey Viv, if I set them to blue. Oh, okay, yeah. So that's all you get for the lights right now. That tiny little reflection. It's also just too bright right now. There might be some background noise in my mic. I have the window open and I live now in a downtown area. And it's just too freaking hot to close it, so I'm not doing that. To be sure I didn't miss anyone. I did say hi to Bread God. Oh wait, we have two Josephs now. We have Joseph Integrates and we have Lesjoma Joseph. The crib is okay though. It's just you're pretty much looking at it. It's just a little studio apartment. It's not much. Call you Joe? Okay. Put it all on red. Oh wait, yeah, Viv, what was your fortune? You have all the assistance and luck this month to succeed. A month is a specific... I guess you have to be a little specific when you do a fortune. It's 4 in the afternoon here. I am now in Seattle. I basically packed up all the stuff I could in my mom's car, drove up here with her. We got here last Wednesday, and I just tried to sign a lease on a place as soon as I could. I managed to do it on Friday night. The month ends in 5 days. Oh, that's true, Jed. Yeah. Don't have much time to get to the casino. But yeah, I am all sorts of discombobulated. It's hot. I have a million things that I probably still need to do that I'm forgetting about that come along with when you move. I just got my bed literally right before I started the stream. It's hard to point at, but it's literally like right behind me. It kind of blends into the wall because it's light. So yeah, I just unpacked that as quickly as I could, and then it needs like it's memory foam, and it comes like rolled up super tight in a box. So it's really convenient to get shipped to you, but it does need to like expand before it gets to its full size. Yeah, my place is a real mess. I have a bunch of like boxes and stuff just kind of laying around. How many viewers can cram in my bedroom? if it's standing room only, I bet we could crowd 20 people in here. Hey, Syntax. Where the music is just quiet for me, I think. Minus 25, minus 35. It's also just a quiet song. Okay. Your first day of uni, you're running on 2 hours of sleep. That sucks. On the bright side, usually the first day you don't actually learn much. So I bet it was annoying socially, but at least academically it probably didn't put you behind. Party after the first orientation thing, that'll do it. Well, at least it was like a party and you're having fun. It wasn't like nerves. 20 people's a party. I'd say just provide drinks. Like put them in Klein bottles. Yeah, and Klein bottles aren't the best containers. Okay, can I... Let me just mess with my blinds. No, that's as much as they can... As they're... Well, wait, what if I... There's no way this works. If I let more light through, is that going to get rid of the little ray of light on my face? I feel like it's actually better. Chug 3 beers in 40 minutes? Oh my god. If there's a time to do stuff like that, it's when you're starting college. Uni. Just remember, drink water. And don't do anything stupid while you're drunk. Or anything stupid in general. So I got home, I wasn't tired, which is so fucked up. Today I was fine, though. It won't be like that forever, Syntax. You'll get old eventually and feel it. Small shift away from the closet's might. Wait, what, Jed? Like the closet here? Fizzbuzz, I hope you're doing well. I am on new internet. I don't see any dropped frames, and I see healthy connections, it looks like. Actually, well, isn't this YouTube? Green, excellent. That's the exact type of stats that I want. Don't give me any technical details. Okay. Well, it seems like the internet isn't melting down, at least. Just yet to make appearance in person at uni. Oh, I wonder... Yeah, she said she's gonna work on her PhD and bachelor's at the same time. Maybe she has to be in person for the PhD. Are you guys gonna meet? That'd be pretty hype. What, light on your face? Oh, I see. Yeah, that would be my right. But it makes positioning my mic a little bit harder because of the way the arm is. I'm also not gonna be like centered with my monitor. You know, I do have like tape. I could just tape over that gap, at least for today. Where is my tape? It's right there. Okay, you know what? I think tape is... Or wait 15 minutes, that's true. Actually, it already has been, because before... Wait. Okay. I'll just try and sit up straight and then it doesn't bother me. If I slouch, you know, it's actually a good thing. It's training my posture. We're in the same tutor group, so our last name starts with letters near each other. I doubt she'll need any of the tutoring. I messed with my mic positioning now. Okay, I guess I'll attempt... I mean, okay, the other issue with doing math is that off stream, I kind of did everything I wanted to do with Fourier and Laplace transforms. I meant to read 4.6, but I've been too busy, like, trying not to be homeless, basically, so... I could pull something from the differential equations book, too. I have this ready, but I don't know if I want to. Make sure you take a lemon Snapple to your session. Things are more fun when you have a tutti frutti. Oh my god, Jed. I used to love Snapple as a kid, but lemon was by far their worst flavor. At first I loved the peach, but then like I was going crazy for the raspberry. Now it just tastes like pure sugar juice to me, and it doesn't taste good anymore. Long Island iced tea is a good choice. What do the problems look like for Fourier and Laplace? You know, a question I meant to look into is what the hell is the connection between this general Fourier transform between like spaces of functions in the Fourier transform that I learned for periodic functions. The book just gives them without justification. I learned these with without reference to imaginary numbers, so they're like 3 separate formulas to avoid. Or like, you know, you get the sines and cosines individually. You know, it probably would be a good exercise to verify that I get the same result with these formulas as with the whatchamacallit. Hey Lucas, is looking weird? It's supposed to look weird. Me or the background or both or everything? I did move. The background? Yeah, I have moved. You also moved. How far was your move? Inches. Oh, that's a big move. I think I feel like I did 13. Could try 14. Oh, 14 parts A through D. Bruh. No, you can't really prove a definition. Like, it doesn't make sense in the first place to try to prove a definition. You use a definition to do other proofs. Or it's not other proofs, but you use a definition to do proofs. Yeah. What's the epsilon-delta definition again? Let me look it up, because I probably figured it out just by starting to write it out, but let's not guess. Yeah, that's like the end of it. So yeah, you wrote basically this piece here, that the actual value of the function minus the proposed limit can be bound arbitrarily small. And the thing you have to show is that this delta exists. That like delta is a bound on your input values, epsilon is a bound on the output values. Also, my voice feels really different right now. I think it's because the room is just shaped differently. But I'm getting kind of tripped out by the sound of my own voice right now. You don't... I mean, it's hard to understand. Yeah, like the epsilon delta definition formalizes the idea of a limit. So if we were to think about just kind of like a function with nothing special happening, And let's say this is the point of interest here. The x coordinate is x equals c. I guess the y coordinate is going to be L. Yeah, Snoop Tiger. That's kind of what I'm trying to recreate right now. So think about like that piece there. I shouldn't use green on green, but formalizes the limit definition. So what I mean by that is you and I both understand what a limit does, like kind of in terms of like pictures. Like it describes how the function behaves around that point. So like if you have a function that goes like this, limit at 0 is infinity. Or if you have a function that goes like this, the limit to as x goes to infinity is whatever like that height is, 1. But the thing is, when you're doing actual math, that picture, it's not a proof. We need to be able to actually prove things about, or we need to be able to write an actual proof for this idea. And so that's that, I guess, process of going from just an idea to a rigorous math definition is called formalizing. So this is formal, whereas the thing that I just said before was informal. Syntax, yes, it's only slightly different. I think you just mess with this a little bit. Like, there's no longer an absolute value, depending if it's left or right. I looked at it before. I don't remember exactly, but you only need to do a small modification to this, as far as I remember. Can you just say f of x equals L, and there exists an epsilon that is bigger than 0? Hey, Dessen. I mean, so we can specifically say f of c equals L from the way that we kind of are defining this function here. That's not always true for limits, though. A function doesn't have to be defined at that point. There exists an epsilon that is bigger than 0 such that f of x minus L is greater than 0. The issue with what you put there is that epsilon isn't involved in that equation. You're saying yeah, so I guess you see it now, but like this thing here needs to involve epsilon in some way is the issue. Dessen, it's just a regular apartment, but yeah, it's my tiny studio apartment. But it's not, it's by campus, but it's not official like campus housing. But it's on the hardest math of your life? I sure hope so. You haven't clarified epsilon's slightly bigger than 0, though. Technically, when you do these proofs, you need to account for any epsilon, even like really big ones. That's usually more of a throwaway afterthought thing. Like, really small epsilons are the interesting ones. The big epsilons, they don't do much for you. The reason for that is because like of what this thing means here. Epsilon is basically an error tolerance. And the error that we're measuring is how far f of x is away from L. Because when you take two numbers, f of x and L, subtract them and take the absolute value, that's distance. Like you think of this thing here as just a distance between two numbers. Two interesting numbers, but it's just the distance between two numbers. And for limits, we're interested in trying to make that distance as small as possible. And so that's why we care about small epsilons. To take care of big epsilons, it's usually just like a one-line, like throwaway thing. I forget exactly how it looks. It usually involves like the maximum function. Or maybe minimum. That makes... Oh, good. Yeah, I don't think it's that hard to understand what this definition is saying. Actually using it is a different story, but once you give yourself time to like think about it, I think the definition is pretty understandable. And so the representation a lot of people use is epsilon represents an error tolerance that might look like this with the outputs, and delta could represent an error tolerance that looks like this with the input. But importantly, they correspond to like the same points here and here, and you have to show that there's that correspondence there. Zach, hey, hope you're doing well. Basically, the difference between 2 points can be infinitely smaller than any number you can think of. Yes. Like if I give you some tiny number like 10 to the negative 9, you can find some delta that gets you within that distance. And so I'm not sure what you mean with the not necessarily correct. You do have to adjust the definition if you want to talk about limits to infinity. Like you need a separate definition. What about the 10 to the minus infinity? Hey, Catmaster. Well, 10 to the minus infinity isn't a number. So, like, this definition relies on this C here being a real number. in 10 to the minus infinity, you can think about it as a limit, but like 10 to the minus infinity itself is not a number. It, if you want to think about like 10 to the minus x, it would go to 0 as x gets very large. But that's not the same. That's not. It wouldn't be right to say equals. And then I'm not sure what you were limit as x goes to 0. This greater than symbol that you wrote is throwing me off. Okay, I don't know what you meant by that piece. You have greater than and less than limits. Oh, maybe the notation for you is or yeah, this might be like a regional thing with like the notation. Are you talking about like limits like like you can talk about a limit that goes from the left or a limit that goes from the right? Is that what you're talking about? Like only from one side? To avoid big delta epsilon, we can choose I, the interval, to be finite. Instead of looking at R, we look at -1, 1 to avoid hassle. I assume you mean big epsilon. That makes sense to me, syntax. I imagine to do things rigorously, it would add a little bit of extra work to do in saying that like the function you cut out the piece of still corresponds with the kind of entire function over the whole domain. I don't see an issue with that, at least. Syntax. The way that they deal with it normally really isn't that big of a deal anyway, though. That's always been a weird step to me, so I don't remember exactly how it works. But yeah. I know that in the interval minus CC there exists a 0. That does sound like the intermediate value theorem. It's talking about like it's not related to the thing you just said with one-sided limits. But there's a theorem that says if a function has a negative value and it has a positive value and it's continuous, then it must have a 0 somewhere. Yep. Bolzano's name is on a few things in this part of math. So, okay, this is just AI stuff, but Bolzano-Cauchy theorem is another word for the intermediate value theorem. Zach is talking about something called Bolzano's theorem. Oh, it's still just the IVT. Your charm and courtesy will be advantageous to your goal. It means that you're good with people. You're polite and you make them like you, and that's going to help you with your goals in life. So it's a nice fortune. Hey, Atharv. Courtesy is being polite, saying please and thank you, holding the door open for people. Yeah, exactly. Tonight's a night sleep in a eucalyptus tree? What is that, Fortune? Oh, a corollary is Bolzano's theorem. Oh, right. I remember this, Zach, where when we proved this, we basically did it for Bolzano's theorem, but then the general statement follows really easily by making a vertical shift. Oh, and I remember this being like a bonus question too. Just think about what that means. A surprising amount of counterexamples to things that seem obvious though, so it's good to be extra careful in proving things even when they sound easy. Yeah, Catmaster, that's true. That's the entire point of real analysis, I guess. Any Cantor set fans? Oh yeah. Rolle's theorem, yes. I always forget. I mean, these theorems always get mixed up for me. I can never keep the names straight. Yeah, it's this one. Okay. Lagrange's. I bet I learned that by a different name. Because you're probably not doing group theory. Or square theorem. Probably not that. Oh, wait, mean... Oh, mean value theorem. That also goes by Lagrange's. Interesting. Hey, Default. We're talking about calculus slash real analysis. It could go in either of those categories. Yeah, Lagrange's done a lot of things. Like, just look at this Lagrange's theorem page. Hey, Vatsal. Complex analysis is also real analysis. Yeah, that's true. Like, real analysis, you could consider it contained within complex analysis. Usually complex analysis has a different kind of focus, but you could think of it like that. Srishti, yeah, I like to think so. I was just watching a Veritasium video where Lagrange came up as a character. I forget what it was, though. Oh, I think maybe it's something about him working with Euler. I don't remember. Great improved by helping people? Oh yeah, absolutely. Srishti. Hey, Default. FBI hand thing? I don't remember that. From that physics class here, probably a physicist. Physician is a doctor. It's really weird, but that's how English works. You took the qual. Ooh. How do you feel like it went? Doing trig for 4 hours straight. Now it messed up my mind. Oh, yeah. Trig will do that. Trig is a very tricky one. Rick Persh. Yeah, the Lagrangian. I remember. Yeah, the video I was watching what was about the Euler Lagrange equations. Oh, you know, I think it was the I think I remember which one now. I've been getting a little more into Veritasium. I usually don't watch a ton of math videos, but I started to find Veritasium more and more entertaining. Hey, look, I remember you talking about this video a long time ago, or not a long time ago, but like a few weeks ago. I did watch that. I think it was cool. I think it was this video where Lagrange comes up, or what? It's like a series of 2 or 3, and it might be one of the previous ones or one of the other ones. Manifest, I think I've heard of them. You solved all problems with more or less the right approach. My solutions felt very hand wavy. Ooh, okay. Well, do you know when you find out? Lagrange point in astronomy is where the gravitational pull of the Earth equals the sun, so the net pulls on that point of an object is canceled out. I think a third. That's something I'd love to learn about, and I haven't yet. But that sounds about right. Differentiation? Yeah, that's all. Like, what do you want to know about it? To do with magnets in an electrical circuit? Yeah, I don't remember that, Lucas. Can't recommend any YouTube channel to an applied guy. Yeah. The standard model of general relativity, everything can be simply described in terms of a Lagrangian. Yeah, it's kind of crazy. I've only dipped my toes into the Euler Lagrange equations, but they seem so powerful. You think this Friday? Okay. Well, fingers crossed. What is differentiation? Yeah, sure. I can definitely answer that. That's all. How hard is it to start to understand physics as someone who is terrible at understanding things in a 3D space? To start, not that hard. I think there's gonna be a weird thing where at the start it won't be that hard because you usually work in 2D, and then it'll get very hard as you bring things into 3 dimensions and the weird coordinates they throw at you. But then I think it might even get easier because then they start talking about like 4 dimensions and things that no one can visualize. So the playing field might be equal there. But to start, I think you'll be okay. It's hard not to know anything about Lagrangians. Your typical pure math enthusiast. So, Vatzel, what is differentiation? Well, the stupid answer is finding the derivative of a function. But I promise I'll explain. That's not the entire answer. So this is how I'm interpreting your question, where kind of what is a derivative. So that's where I'm headed. Let me know if that's not what you want to hear about. The derivative of a function. Oops, I bumped my mics. Sorry. The derivative of a function is the rate of change. So, what does rate of change mean? If we just have a function. Let me draw like x cubed. Let me draw it a little better. No, okay, never mind. I'd rather draw. Let me just draw a random parabola. Sorry. Let's just take some random parabola. It doesn't matter which one. The rate of change, what we kind of do when thinking about rate of change is choose any particular point you want. Let's just choose that one. We say the rate of change here is the slope of the tangent line. The tangent line is the line that just kind of glides along it and only intersects the function once. That's not a perfect definition, but hopefully visually you can see what's happening here, where it's just you just kind of like with a line follow along the shape of the function at that point. Sage, hello, or sorry, hey Sage. Thank you. Let me catch up with the chat and then I'll get back to this. Differentiation, finding how a function follows a path, how steep does it go? Yeah, in a way. If you ever become PhD advisor, what do you think will be your biggest red flag? Ooh. Is that the Chinese flag? That is a big red flag. I don't know. Probably if I get the feeling that something is generated by AI. Japan flag is a big red flag. Well, it just has the dot, right? Distinction between theoretical physics and math is the same as distinction between linear algebra and matrices. Ooh. I need to think about that more, Rick. That's an interesting statement. Current year will bring you much great / much happiness. Oh, nice. Seize the day. Fortune says you can have it all. Hey, okay. Hey, Dinesh. Anon. Yeah, sure. If it's JE, I probably can't do it. Oh shoot, my streamer bot isn't connected to YouTube. But other than that, I can take a look at it. I've been into calculus for so long, sometimes you really figure out the basics. Yeah. Okay. So back to derivatives. The rate of change of a function at any point is the slope of this line. So JE advanced. Oh, I'm sorry, Anon. I've tried those before and they're just a little too tough. Oh, your teacher just gave you formulas to memorize? Oh yeah, that's not good. Hopefully this will help. So the thing to notice with a parabola is that at either end, it's going to get steeper and steeper and steeper. The further up either side you go. It's kind of like for a small change in x down here, you get a very big change in y. So like, here's the change in y right there. Sorry, it's just like that piece there. Versus if I come over here and do a little change in x, I don't get very much change in y at all. So that's another way of thinking about it, but the most important piece of this is that it's the rate of change, and the rate of change is the slope of the tangent line. So like right here at the bottom, there's zero change just for a moment when the tangent line is perfectly horizontal. Gonna learn some French vocab. Oh, good luck, Lucas. How much does electricity combine in physics? You don't really like electricity? You can, if you're doing a degree, they'll make you learn some about it. But you can do a lot of physics without doing any electricity. You're gonna have to get through some like a fair few amount of classes if you study physics, like if you were to like major in physics. We need 2 points to find a slope. Yes, that's a very good point, Fat Cell. And so the next thing I'll say is how we find that second point. Okay, so Dinesh, can I teach about integration? Yes, I can. Just let me know what piece. Like, what about integration do you want to know? Can I teach logs? I can teach the basics of logs. If there's some JEE Advanced always makes me nervous because they do weird things that I don't know about. So I would feel a little not confident trying to help you with logs. They see a compilation of that of Tharv, I would hate doing that. So, yeah, Tharv, let's talk about how we find that other point. So I'm going to choose a point here to find the slope at, and I'm going to say that's the point a comma f of a. So just like the x coordinate is a. Good luck, Anon. And so the limit definition of a derivative there's two different ones that are popular. I'm going to show this particular one first though. The limit as x approaches a of f of x minus f of a over x minus a. This is just the formula of a slope. But it's the slope taken at two very particular points. So one of the points is our point of interest that we're taking the derivative at. The other point is this x thing, wherever it happens to be. But the magic of this is x is getting arbitrarily close to a. So it's like I'm taking a point really close to a and not quite at it, and taking the slope between those 2 points. That's what this formula does. And sorry, Lucas, I haven't been able to keep up with your questions. I'm not sure what you mean with differentiation being smaller than integration. Integration also involves a limit going to 0, though. Biscro, I can do that once I'm through with this explanation. Oh, Destin, I forgot to watch it. I saw other videos where Shortcuts was interviewed, and that made me forget about the actual one that you linked. I still have it in my watch history, and I still want to watch it. He seems really well spoken though. So yeah, Vatzel, it's not truly tangent, as you say, because it is hitting the function at 2 different points. But that's okay. It doesn't need to be perfectly tangent. And so honestly, calling it a tangent line isn't like it's not a perfect word. See you, Lucas. But that's the idea of what we're trying to find. Like, this is how we can mathematically find a tangent line once x gets close enough to a. But you're right, like it never is truly a tangent line. But it doesn't have to be, I guess. Can we say the derivative is the perpendicular to the line that describes its curvature? That is the thing, right? Then there's like normal lines too. Can I explain an AC generator? No, I don't know anything about generators, unfortunately. Inverse functions, yeah, we can talk about those too with domain and range. Master trig for calculus? Unfortunately, it's just a lot of practice, Anon. There isn't a way around it. Just gotta get used to the tricks that they tend to throw at you. And so yeah, the other definition of a derivative, it's not substantially different. Like, it's saying the exact same thing, but it does look a little bit different. The limit as h goes to 0, f of x plus h minus f of x over h. There's a way you can go directly from this formula to the other one with a change of variables. I forget exactly how it looks, but these two formulas say the exact same thing, basically. Yeah, you kind of just need to know the formulas. But it's also just kind of like the techniques too. You two are talking about what a derivative is. We've had a few other questions come in after this, but I'll have to catch up and remember who asked first or see who's still here. Shivam, is it necessary to be an expert in mathematics for computer science? No, I don't think so. There's some niches in computer science where math is more helpful than others. But I don't think you need to be an expert in math. Dinesh, I think I can do that integral. Oh yeah, I can definitely do that integral. Fatsal, it is an approximate. Approximation is the right thing to think about. Because we're using an approximation and we're making it, in theory, so close to what we want that we can just say it is the exact thing that we want. Like, even though this comes from an approximation, we say it is exactly equal to the derivative of f at a. That's the beauty of this limit here. We take an approximation, take the limit of it, and we get exact equality. Atharv, yeah, 3 blue, 1 brown is great for explanations like this. Dinesh, yeah, we can do that after. Oh, Snoop, yeah, thank you. That's a change of variables that you would probably want there. Regression mathematics, like in statistics, you two? I remember like how to get a regression line. I don't know if that's what you want though. Rotational motion? Ugh, my rotational motion is really weak. Wait, Famished, did I already say hi to you? I can't remember now. If not, hi, Famished. I talk about the definition of a derivative, which is one of the things you learn early on in calculus. Approximation plus limit equal precise, exactly. So what the hell is instantaneous velocity? 0 over 0 doesn't make sense. Instantaneous velocity is just a derivative in a specific context. The context is if you have time and position and just some random function, the instantaneous velocity is the slope of the tangent line. So like right at that point, your position is decreasing, so your velocity is negative. You two, I need to be a little more specific. 0 over 0 does not make sense. You're right. We would call that indeterminate. But we could talk about something like, just to throw a weird example at you. The limit as x goes to 0 of sine of x divided by x. This looks a heck of a lot like 0 over 0, because sine of 0 is 0. But it's actually possible to prove that this limit is 1. And it's a pretty important result. So when limits are involved, 0 over 0 is okay in a certain sense. It has to do with how quickly they go to 0. There can be infinite number of possible solutions. Yeah, instant velocity of a small change in position time. Exactly, a knot. So there is a time interval involved in instantaneous velocity. That's all, yes, but that time interval is going to 0. So it's the exact same thing here, where like we can write out the exact same definition. Let's say we want the instantaneous velocity at that point. I'll say x1 t1. Sorry, I have that backwards. t1 x1. We can take some other point here to get an approximation for the instantaneous velocity. t2 x2. It can be like also up above 2. It doesn't matter. What you would do is take the limit as t2 goes to t1 of x1 minus x2 over t1 minus t2. But this is the exact same thing as the derivative definition up here. And this is indeed a distance divided by a time. That time interval is getting extremely small, but that's okay. That's the exact thing that we want. Oh, yeah, I'm not talking about anything rotational with torque. Might do some review of intermediate algebra. Oh, nice. Famished. I hope it goes well. How do you do arithmetic sequences? I'm not very good with those, GCG, unfortunately. See many Indian brothers are here. What a coincidence. Yeah. I don't really want to say your name, but everyone's welcome in here. Oh no, Ashutosh, that's good to know that torque actually affects this, because I didn't know that. So thank you for saying that. I was just to try to be clear for Batsal, who's asking the question, that the stuff that I'm saying here at least doesn't involve torque. If torque is in there, maybe something needs to change, but okay. So if you have more questions about this, let me know. But I have been brushing off a few other questions. So Dinesh, are you still here? Do you want to hear about this integral here? Torque of acceleration. Oh, okay, fair. Collatz conjecture. I wasn't able to understand a point about it. Yeah, I've seen the Collatz conjecture before, Atharv. I can try to help. I might not be able to figure it out, but we can talk about it. Is it wrong to say the speed at t equals 3 seconds is 4 meters per second? No, that's fine. I thought with this person, they might have dipped out anyway, so if they're not still here, then I'm not going to work on it, which that's my bad for taking so long. So yeah, that's all. You're right. There's a time interval involved. But kind of the entire magic of derivatives is that we don't have to worry about the interval. We're making the interval so small, it doesn't matter. That's kind of like, that's the stepping off point of calculus. Realizing that this limit thing here can get you the exact slope at a point. Not just an approximation, but the exact value. Oh no, my hotkey doesn't work. Why does that not work? One second. Okay, I have two things that I need to fix for the stream now. Let me write this down because I'm gonna forget. Don't play music on starting soon. Fix hotkeys. Color cone. Oh, it's great. So many bedrooms, so much space. I have 5 different golf carts just to help me get around quicker. No worries, Fatsal. Thank you for the question. I hope that you're doing well, Collar Cone. So Tharv has a specific question about the Collatz conjecture. How's so big I can't find the bathroom? True. Oh, and yeah, that's all. Just like one last thing. You'll probably get given a bunch of formulas, like the power rule, for example. All of these rules, like this, come from this limit definition, either of these. So, like that's where all those formulas actually like come from. In case you were like curious. Okay. So if n is even, divide it by 2. If n is odd, multiply it by 3 and add 1. Yeah, Aditya. I'm starting on September 22nd. So just under a month. Thinking about your basic ideas to prove the conjecture wrong. Exactly, Tharp, yeah. Finding a counterexample. No, it's not very common, collar cone. This is the latest I've ever started school. It's because usually we use semesters, but UW uses quarters. And so for whatever reason, quarters start late. Any Calc 2 tips? Calc 2 is kind of a rough one with how many integration techniques they throw at you. The thing I kind of generally give to people is pause on my notes, because it has really good examples of everything that you're going to need to know for most purposes. Like integration techniques is usually like the tricky bit. So I would just look through these for anything in particular that you're having trouble with. Yeah, so I've got a good bit of downtime to explore. And this is for geometry. Geometry is a tricky one because it's so different for everyone. For geometry, I guess there's not much you can do aside from practice. It kind of, I don't feel like there is a good tip for much of like questions like that. So the article you're reading stated negative integers have these loops to exist, and you only get how. Ooh, I never thought about negative integers. It looks like the conjecture only talks about positive, but let's think about it for negative. I guess negative integers will just be a slightly different version of the same thing. Um, Shivam, what did you ask? Sorry, there were quite a few questions that came up in the YouTube chat, and I lost track of them. That's about being an expert in math for computer science. I answered that one. I said probably not. I'm still scrolling up. I don't see anything else from you. If I missed something, I'm sorry. Please repeat it. Um, yeah, maybe Tharva. I kind of want to do some example negatives and see what comes out. Let's just take like -5 just to do a small one. So I definitely do not Sharda. I'm sorry. I've tried them before. They're a little too tough for me. So -5, we do 3 times -5 is -15, plus 1 is -14. That's even, so it gets divided by 2, -7. Oh, is this just blowing up to infinity? Because now we're gonna get -20, right? Oh, I guess let's keep it going. Divided by 2, -10. Divided by 2 again. Oh, we get a cycle. Oh, no worries, Sharda. That's kind of funny. So this one never goes down to 1. Yeah, and like I think if you were to ask someone, if you were to ask like someone who's maybe more rigorous about their math, you could, like, this would be equivalent to just taking a different definition of n. Like, we don't have to talk about negative numbers at all. If we just make it like that. Like, we could say this function only applies to positive integers, and it'll be equivalent to this thing up here. So I think mathematicians would consider a different question. This makes sense if you think about it. Well, so is this going to be true for any negative? Oh, you're saying it should be 3n minus 1 to hold for negatives. Yeah, I think that would get you the equivalent statement. That would get you, like the same thing, but for negative integers. Dave B. Math, thank you for the follow. Yeah, Tharp, that's an interesting thought. I never thought about Collatz conjecture with negatives. What happens with like -6? Okay, so this one is gonna get into a loop, right? Oh no, is it? What does -1 do? It goes to -2. Okay, so yeah, that's gonna get caught in its own loop then. Okay. Um, you can see patterns like these. Yeah, Tharp, that is kind of a neat thought there. Shivam, given random variables. Oh God. I don't know how to begin with that. Is that some statistical mechanics thing? Yeah, I'm sorry. I haven't done that in my life. Okay, if someone has a question, let me know. Otherwise, I think I'm gonna pull some question to study for myself. But yeah, there's been quite a few people who asked questions in the YouTube chat earlier that I said I would get to later and haven't. If you're still around, please speak up. Why are numbers? Because they think, therefore they are. I hope we're doing well, Mega. Um, that's like a Drax thing. Was it Guardians of the Galaxy or was it Infinity War? But I said, why is Gamora? My courses? Yeah, I'm in my courses are that I'm registered for: applied complex analysis, mathematical biology, and scientific computing. I'm nervous for applied complex analysis. I think it's probably going to be my hardest class. Mathematical biology, I'm excited to learn about. Scientific computing, I'm neutral about. I'll probably like it. I'll be able to learn more Python. Yeah, and I think honestly, the book I've been reading about the applications for it, it's been kind of light on the applications. It's mostly been like they talked a little about like fluid dynamics. They've been teaching a lot of techniques that they say are used in applications, but not saying what the applications are so far. Data science over machine learning. I guess that makes sense. But yeah, I'm sorry, I don't know anything about machine learning. But yeah, Tharp, I'm gonna be doing a master's in applied math. The Mukai Fourier transform, I definitely have seen that. I assume you're asking that ironically, color cone, but I want to remember what that looks like. It's purple. I have seen it. Oh, yeah. Okay, yeah, that's an ironic question. Oh, okay. My monitor just went black for a second and I got scared. It came back though. To go back and forth between a group and its tensor category of representations. The monitor got scared. My monitor doesn't like category theory. No worries, Shivam. It's always better to ask the question. The worst I can say is I don't know. Hey, Mouse. It's late for you. Oh, well, oh my god, I'm stuttering. Thank you, Shivam. Fembox, hey. I hope you've been well. Oh, you're muted? Well, hi, Mouse. Hope you're doing well. How's the new place? It's very small. It's good enough, but it's not my dream place. That's my bed, like right behind me there. Don't recognize the stream without the flag. Hey, Skirtle. I know, I need to figure out a way to hang it up. It's polyester. And I thought I saw online like a long time ago you can make some like cornstarch mixture that somehow works. But yeah, all my posts and stuff are just kind of sitting on the ground, lean against the wall right now. But yeah, like everything is broken in my place. The landlord thankfully is kind of on top of it and fixing stuff, but like the fridge didn't work, the oven still doesn't work. There's a leak in the bathroom sink. There's like mold growing on the walls. I was like, I had to sign a lease quickly, so I was pretty desperate. This place has definitely been making me nervous. The only thing that's giving me hope is that the landlord is genuinely on top of stuff and trying to like bring it up to speed. So no mice, thankfully. Use the flag on my head. Yeah, there we go. Make a hat. Can I fit my fancy coffee machine? I don't have a fancy coffee machine. I would love one. I just have a kettle and basically a funnel. Be poison mice. You have to inspire him. Bandana, yeah. Rent. This is 1,300, which is still very expensive relative to the rest of the world, but is way cheaper than where I was living in California. Lead and asbestos. True. Well, hey, it's not too late, Skirtle. Maybe we'll discover the 1,300 USD. 450. That sounds like a dream. That's so expensive, Skirtle. For me, it's cheap. Dondo's coffee. Rent a 3-bedroom here. Oh my god. In a basement studio and it's $925. Oh geez. It sounds like you still live somewhere that's pretty decently like high cost of living. Oh, you don't have rent? Well, lucky you, Skirtle. Oh, thank you, Shivam. But yeah, my only like, well, I have like a grinder too, but let me. This is basically all the coffee stuff I need. Let me. My hand is it. Wait, which hotkey is it? There we go. This is pretty much all my coffee stuff. Kettle, V60, funnel to actually brew, and then grinder. That's all you need. Well, that's all well, it's not all I want, but it's all I need. You own your house? Oh, nice. You're in a basement, 1 bedroom, and it's 920? Jeez. Grinder the dating app. Yeah. All you need is Grinder. Hey, creative. Solve JE paper? I sure can't. I can't do that either. I'm sorry. Go to Lisbon and increase your 700 or more? That still sounds amazing, Poison Mouse. My 1-bedroom in California was 2,200. So just checked in your rent. It's how much I'm renting out a 3-bedroom condo plus parking for. Dang. Papadoria, hey. You want to be my landlord, Skirtle? Oh yeah, and the second I call you to like fix something, you're gonna be too busy with your horse girls. Just gonna make me deal with it. I mean, it's all relative. Like, when I was working my office job, that was still at least half my income. Okay, you know what, Skirtle? If that's how it works, that sounds amazing. I would love for you to be my landlord then. And especially if I can get a discount by playing Repo with you. So yeah, Papadoria, I moved. I was in California. I'm now in Seattle. That's done to Microsoft. If they'll hire me, I'll work there. There is a bunch of stuff named after Bill Gates on the UW campus. I just passed by a Microsoft cafe and I was like, ooh, do they have computers there? And I looked inside and no, it's just a regular cafe named after Microsoft. This gotta be suck up, George. Oh no. Damn it. You drive a hard bargain, Skirtle. Was the move good? It's worked out, Papadori. It was really stressful because basically what I did is I packed up all my stuff that I could. I had to throw away a bunch of stuff into my mom's car. We drove up with all my stuff. It's a 13-hour drive. We split it up into 2 days. And once we got in town, I just had to sign a lease as quickly as possible because I didn't want a car full of everything I have in the world just sitting there. And see, I found a place that I'm not entirely like enthusiastic about, but it's good enough, and the landlord seems like a good person, so it seems like it's working out. Is there a cafe called the Blue Screen? Probably somewhere. You want to visit the US someday? That'd be awesome, Mouse. America's a lot of cool stuff. I'm trying to move countries. Have you moved countries, Skirtle? Because, yeah, that sounds terrible. Yeah, exactly, Papadoria. Oh no, Femlux. I sold my car before coming up here, and I feel kind of happy to do the public transportation life for a bit. Driving it's kind of like, I don't mind it, but it's like it comes with a lot of anxiety. The public transit here is pretty nice too. It's not activated yet, but the student ID works as a it's not free because they charge you as part of the tuition, but it comes with like a transit pass that you don't pay any extra for. The intersection, yes. You have countries 5 times, Cyril? Oh my god. Like, like that sounds so annoying that A, you need to throw out or store a bunch of stuff, and then B, probably need to pay a company to move your stuff on a boat or something, I bet. Cars are expensive? Yeah, Dr. L, especially here, there is no free parking. It just does not exist. Yeah, really, please just speak English. So yeah, there's no free parking. Like you have to pay everywhere. Even if you like stay at a hotel or rent an apartment, they charge you per day or per month. The intersections are wild. Let me bring up the article, because they've written articles about how wild the intersections are in Seattle. It's a really confusing place to drive. So an artist did this like representation of some of the worst intersections in Seattle. I wish I could make it bigger, but I can't. And yeah, these are real intersections. This one might be the worst one. It looks like a stingray. Daisy Dukes and a gun and a fork to hunt zombies. Oh, that's weird, Mouse. You probably have the cursing filter or the language filter on. Fenlux didn't curse, but that's the only thing I can think of. Could be an alphabet. Yeah, Skirtle. I posted this in the Discord and I joked that like there should be a game of like, is this a Seattle intersection or a Chinese character? Yeah, Rohi, you can just put them in chat. Thank you, Papadori, for helping out with that. It's enabled by default, mouse. So like I've gotten like bit by it too. I have extra stuff that you won't have because this is my channel. It's one of these settings in this cogwheel. There's way too many things for me to find it right now. Oh hey, if this impression went live, we'll have someone to raid. It might be an appearance. No, I don't know. It's somewhere in there. Recursion? Yeah, true. Igloo, pass your abstract algebra class? Hell yeah. Graduated? Congrats. Budget analyst for someone that manages HOAs. Hey, you know, if it pays the bills, it's a start. But hey, graduating and landing a job is huge. Yeah, like that's how Twitch will censor things. It does the same thing with links too. I have links turned on, so it wouldn't have been that. But if a streamer turns links off, then it'll replace them with asterisks. Physics, it depends on the question. If you want, I can ask it and I can tell you yes or no. My physics isn't that strong though. I don't know if Fembucks Twitch is trying to like keep you down, maybe. They don't want you spreading the word. You're so benign. John Vic, yeah, feel free to post your question. I can take a look. Stoke, hello. I hope you've been well. Guncrats, I like that. Going to bed? All right, Mouse. Thanks for hanging out. Oh God. Really, we can try with that. Weird a couple days. It's been a good month. All right. That's fair. It's also been a weird couple of days for me, so. Okay. Oh, geez. I saw that for a second, John Vic. Did you say that? I guess I'm not surprised, Mouse, but I don't know. I try not to go into politics on the stream, but that's not something that I would say personally, I guess. Yeah, the YouTube limit is very annoying. Oh. Okay, I 1 minus x to the 1 over x minus e to the minus 1 over x to the a? Is this the question? Oh yeah, Discord you can post images and they have a much more generous limit. What the hell is happening here? So this is like 1 to the infinity. This is like e to the minus infinity? Well, it depends on the sign of a. It depends on the sign of a. Ariane, I'm not going to do that. Yeah, this has a JEE feel. You still said that they mean square root. Good night, mouse. E2 minus 1 divides the whole x to the a. So it's more like that. G Advanced 2020. Okay. Yeah, I've tried JEE Advanced questions before. I normally can't do them. And this looks like one of those. um the whole thing. Okay. So yeah, please keep it English. See, I don't know exactly how L'Hopital's even applies here. Because we definitely have this bit here being indeterminate. But it's not just that. We also have that denominator there messing with stuff. It's like 2 indeterminate forms in one. And I don't know how L'Hopital's even works in that situation. Because it's like 1 to the infinity over infinity. I guess over 0. The first bit tends to... Oh, that is the definition of E. Oh my god, Mega. I didn't even see that. The answer to the question is 1. Okay, so that's a good spot, Mega. That does like the limit definition of E. So I guess we can L'Hopital's. Because we do have 0 over 0, as long as A is positive. Yeah, you can type it in parts, Tizzer. I see. Rohit. Oh, we're I thought you were trying to like I thought you were trying to figure out how to get one, but are you okay? Do you just want to skip past this? Yeah, John Vic, I really don't know about that question. I assume you put a 6 there. I assume it's not supposed to be there though. Uh, I'm not sure who the question is, John Vic, but I think I definitely can't do it when we're talking about matrix powers like that. So yeah, if it's a JE question, I'm sorry, but I almost definitely can't do it. So wait to see what a Tizzer has to ask, but um, J is not that tough. For you, maybe. For me, it's very tough. I've tried them many times before, and I tried one just then. A Tharv, it's definitely paid. It's like a degree program. It's not cheap. Um, because it's just how education works in America. You pay a lot of money. It is a big question. Code Force is a question. I've never done those. I just saw what Joseph integrates posted in the Discord. It's funny. Um, yeah, D, that's kind of the problem. I don't know the patterns that J uses. Zero dynamics text, football being thrown. Milk, yeah. I'm in Seattle now. I don't have all night to stream because naturally my landlord is coming here potentially as soon as an hour to do a repair. America's trying not to delete savings for college challenge. The only way to beat that challenge is to go into debt. But keep your savings. 32.2. Oh no. The person is running. Oh my god. I assume this is b of t. Wait, no. B is a constant. Maybe b sub t? Maybe, I don't know. Alright, I guess let's make a drawing. B times t. Oh, I see. That's their acceleration. Oh gosh, okay. That's okay, so I think we can work out what the image should be. So they accelerate. A of t is equal to b times t. Find the constant b. Okay. Well, I think the first thing to work out is where this ball lands. Because that's something we don't need to worry about the person with yet. So its height is... It starts from height 0. It has initial speed v0 sine theta t minus 1/2 gt squared. The x component is v0 cosine theta t, and there's no initial x value. And so we're interested in the horizontal distance it travels, because the person who's traveling horizontally is going to catch it. And so when y equals 0 is when the ball hits the ground. So we're going to take that bad boy, set it equal to 0. Solve for time. Oh, you guys can't hear that seagull. Would have been good proof that I did actually move. So solving this for t, t equals 0, which we don't care about, and we get t equals, mental math, 2 v0 sine theta over g. My g looks like 9. Okay, so this time right here is when the ball hits the ground. We can figure out what the horizontal distance is by plugging it in up here. Do I have a seagull as my pet? No. If anything, I am the seagull's pet. The seagulls are gonna take over. I feel weird about having a v0 squared. No, that does make the dimensions check out, right? Yeah, we do need the v0 squared. Okay, so this is the total horizontal distance the ball covers. Can I see my McDonald's? Yeah, basically. And so now we know in the same amount of time, this person travels this same distance minus d because they had that head start. I bet there's a way just with that information that you can logic something out. It's not coming to me. But we can also talk about the person. If we know their acceleration is bt, I hope you know calculus, because it's massive lol. Okay. I'm just gonna hope that, okay, you do. So if we integrate each side of this, we get velocity. The person has no, sorry, it's not good to use v0. I'll say v1 for the person's initial speed. Their initial speed is 0 though. They don't start on a run. Like they start at rest because the question doesn't say otherwise. So it's just oop, I'm sorry, I didn't actually integrate. That's kind of important. Sorry. We're integrating in terms of t. So we use the power rule. And then we can integrate again to get position. And then their initial position was distance d away. So I'm just going to put that d right in. That's what she said. And now I'm hoping that now I have this equation, we can... Ooh, yes. Because we... it's the same amount of time they've been running for. So we can take this same time and plug it in to get where the person is at the end of this. Yeah, this will work. This is going to get massive. Oh my god. So that's where the person, well, okay, so that's the person's position at the time the ball hits the ground. It looks terrible. I guess we can try to simplify it. Hey, crap. It's a really annoying physics question. It's too big to even, like, properly fit on the screen, but yeah. Involves throwing a ball on a person, like, running at the same time. Like, I guess I'll break out this cubed. I don't particularly want to. Ooh, 4, 3. It's Tom Brady's problem. ChatGPT's approach? I don't need ChatGPT. I don't really like using it. Okay, so the reason that we want this thing here, or even this, is because we know that this position should be the same as the ball's position. Because they're happening at the same time. The person catches the ball. So the ball and the person have the same position at this specific time. And the goal was to solve for B. So we now have a way of actually doing that. And this is where it's going to get really messy. But what we need to do is take this, set it equal to this, and then isolate B, and there's our answer. Oh, this is another JE. Yeah, I can imagine there being some formulas to just cut straight to the chase that they would expect you to memorize for JE. I don't know them though. Rotten C. Hymicus? Thank you for the follow. Alan, I can help with anything that's like calculus and below. Hey, Nandish. It's like first year undergraduate math and below is what I'm best with. You've heard Jay's just a lot of memorizing formulas. From what I've seen, that sounds pretty accurate. So, okay, we want to isolate B. Let's subtract D to the other side. You know, J question when you see one. Fair. So, okay, I'm multiplying by 3/4 G cubed. It's not J. Oh, okay. Okay, and then I think just divide out the V naught cubed sine cubed. G complex numbers to the locus. Honestly, I probably can't. Alan, I'm sorry. I've tried JE problems before and I normally can't do them. I didn't understand that last step. Tizer, what I did is I took this equation here. I multiplied each side by, I'm doing it in kind of a weird way, but I multiplied each side by 3/4 G cubed. Like, however you want to isolate B is fine. For whatever reason, this is just what felt natural to me to start with. This is more like a matter of opinion, though. Like, just all we want to do is isolate B, and there's a lot of ways that you can like represent it. Oh yeah, I saw he has one on the Collatz Conjecture. I haven't watched it though. We did the same thing. Okay, yeah. Let's see if we get the same result. Yeah, sure. Evolution, feel free to post it there in chat. Okay, what units do we expect B to be? If T is time, and acceleration needs meters per second squared, B must be meters per second cubed, right? Is this meters per second cubed? Oh my god, this bit over here is. How about this bit? It actually is. The units check out. But yeah, I think this is my answer at the bottom here. Here's my awful work for you to make fun of, Fembuck says. Well, if you're gonna just offer me to make fun of it, then I gotta take you up on that. Yeah, the same thing you think? Yeah, it's hard to tell. This looks vaguely like mine. You never check the dimensions? Oh, Morin is rolling in his grave right now, even though he's alive. He got a grave just so he could roll in it. Oh, we have different powers of G, I think. I'm able to factor out a G squared. You have just a G on the outside. Whereas with me, I could factor out a G squared. Oh wait, no, I don't have a common denominator. Maybe I shouldn't, well, I don't know. It's correct. Alright, Tizzer, no worry. No worries. Illusion. Oh, that sounds terrible. I'll put the problem up on screen. I don't think I know how to do that, though. I'm too lazy to check the units in your answer. Got that a D back in the middle. Oh, okay. Oh, okay. Hopefully ChatGPT was right. Pascal's triangle? Really? Illusion is the name of the person who posted the question. They're up there in the YouTube chat. Yeah, Illusion, I'll hear the solution. I mean, it'd be good to verify it, which we can do with Wolfram, I think. So I think Wolfram will get an approximation for theta. Avert your eyes if you don't want spoilers here. I'll... Well, of course there's periodic solutions. I don't know which one to choose, though. Okay, fine. I don't feel like verifying it. Like, it doesn't get something to do with foiling, I guess. Maybe that's where you're going with Pascal's triangle. Like, you have to think about cosine to the 6 plus sine to the 6 square or something like that. Ever tried to archive? I mean, I've looked at it. I never tried to publish something on it. The cam is dark now. There we go. Yeah, Legion, I imagine we're talking about the same thing, just with a different name. Like, my only other thing I can think of is, like, you could say that cosine to the 12 and sine... Well... Like, you could pull 2 powers of cosine out. I don't know if that does anything good for us, but... Oh, you get it? Oh, wait. No, I don't know if I get it. Because you do the same with sine. I don't know if you want to. Oh, maybe I... We can pull a sine squared out of this. Oh, but then this... It's a minus sign. X squared equals cosine to the 10? X equals cosine squared. You're losing me there, Illusion. I feel like you're using something that I haven't seen before. And that's okay. The important part is that you understand it. um, yeah, no, I'm a little lost. I don't normally solve this type of question, so I don't know the techniques that are involved here. Honestly, I thought Newton's sums. Oh, I thought this would be a name for something I've already seen before, but it's just genuinely something I have not seen before. Damn, powers of sine squared and cosine squared. That might do it too. There you go, Dr. L. Problem solved. All right, well, fair enough, Evolution. Thanks for training with me. I'm glad you figured it out. I think I want to call it here for the day because I'm I don't have very much energy still. uh and I gotta go at some point anyway because my landlord is gonna come by to do some more repairs and fix a leak. So I'm glad the stream went well though. Like my internet seems to be holding up. No dropped frames. Not on YouTube either, it looks like. Insert 69 joke here. That's true. That is classic Dr. L. Yeah, I think that's where I'm going to end it, guys. So people who are here on YouTube, thanks for being here. And then on Twitch, we'll look for a raid. So goodbye, YouTube.